In this unit, we're going to focus on solving equations. In this lesson, we're going to look at equations that require two operations to solve.
Okay, hi everybody. So in this lesson here, we're going to talk about type 3 equations. Okay, if we're going to kind of be consistent with how we've been labeling these things before. So type 3 equations here. And what's going to make this one different is the combination of the two operations that we've done separately. In type 1 equations, the only operation that we were working on here was that addition or subtraction right there. In type 2 equations, the only operation that we were dealing with was that multiplication or division that could have been right there with the variable. Now we're going to do both of them. Now, in order to do this thing, the first thing we're going to do is remove that constant. So what happens here is in these types of questions, what we've got here is we've got two terms. Okay, on the one side of the equation where the variable is, okay, and the variable in this case would be the x, right? A and b both are going to represent numbers here. We've got two terms. Our first goal is to remove the term without the variable, okay? And that's going to require the opposite or the inverse operation to the addition or subtraction that we're seeing right there, okay? And then we've got to get rid of the multiplication or division by, again, doing the inverse operation there. So in the example that we've given you right here, actually, this is probably not a great example, but yeah, sorry, it says right here, remember that anytime a variable doesn't have a coefficient, the coefficient of it is 1, right? If you don't see it right there, it's 1. Anyway, so other things that maybe we should mention right now before we get too far into this is that when you're working with an equation here, okay, when you're working with equation, I'm going to go back up to the one at the top of the page there. When you're dealing with these, I don't know why, it's not erasing. That is so interesting. Oh, there we go. When you're dealing with an equations like this, remember that when they're given to you, they are already in a balanced form. You do not need to balance these equations. So when you see, again, when you see this plus b on this side, I do not therefore need to add a plus b to the other side to balance it. It's already balanced. Okay, that's just a point that really can't be overemphasized here. I see so many students that make that mistake. Trying to do it like that, that we need to balance the work that we do on both sides, so they try to balance it, but it's already balanced. You balance it by doing the same operations to both sides of the equation as you move forward trying to solve. Okay, let's take a look at some examples here. Okay, so we're going to solve the following equations here. So our first one is 3c plus 8 is equal to 101. Okay, so the first thing I'm going to do here is eliminate the second term by subtracting 8 from both sides. And because those are the inverses of each other, 8 minus 8 is going to get me 0. And on the right-hand side, I will get 93. So 101 minus 8 will be 93. Now that I've changed, that I've gotten rid of the second term using addition or subtraction, now I'm going to get rid of the coefficient. Because it's 3 multiplied by c, I'm going to use division, and I will get that c is equal to 31. Okay, and I can double check that. I can go back and plug that in to verify it, but that's what I would get there. Okay, same thing. Let's keep doing, keep looking through problems here, because really what you need to see is just see it done over and over again. So I've got negative b minus 8 is equal to 10. Again, I've got the two terms. I would simplify if I could, but those are two unlike terms. So I'm going to get rid of the term without the variable in it by adding 8 to both sides, in which case I'm going to get negative 2b, and then the negative 8 plus 8 will cancel, get me a 0 there. And then on the right-hand side, 10 plus 8 is going to be 18. Now that I've gotten rid of that addition subtraction step, now I'm going to divide both sides by that coefficient, and I will get here that b is equal to negative 9. And that's my solution. Now, this next one here is just a little bit different. They've altered the operation here just slightly, but again, I've got two terms. So I want to get rid of the term without the variable. So it's because I'm adding 5 there, I'm going to subtract 5, and I have to do it from both sides. That's where the balancing comes in. So I will get d over 4 is equal to negative 13. And now my next step here is going to be to remove that coefficient. Now, you might see that as a coefficient of 1 over 4. You might see this as division by 4, and that's probably where most people will think of this. So I'm going to multiply both sides by 4 to balance that division by 4. So on the left-hand side, the multiplication by 4 and the division by 4 will cancel. They'll get 1. So that'll leave me with a d is equal to, well, negative 13 times 4 is going to be negative 52. This next one, I'm going to, again, my first step is going to be to remove the constant there, the term without the variable in it. And so I'm going to add 8 to both sides. So I'll get 2/3 n. And that is going to equal 20. And now what I want to do is I want to get rid of the coefficient of the n here. So I'm going to divide both sides by 2/3. And yeah, I'm dividing by the fraction, but that really doesn't change the operation. Still division. But it changes how I do that. So remember that this is going to end up being 20 multiplied by 3 over 2. And when I do that, I will get 30. Yeah, right? I'm going to divide, the 20 divided by 2 is 10, and then I would do the multiplication. Okay, now in this one here, a little bit more going on because of that negative there, but it's not a big deal. First of all, I'm going to subtract the 8 from both sides because that's the second term on the left-hand side, and I don't want that. I want to get rid of it. And so that's going to leave me with negative f over 5. Positive 8 minus 8 is going to be 0. And then on the right-hand side, negative 2 minus 8 is negative 10. Now, on the left-hand side, it looks like negative f divided by 5 here. But one of the things I can do with that negative in particular is I can move that negative down to the denominator. Okay, so I can actually think of that as f divided by negative 5 because it doesn't really matter whether that negative is in the numerator or denominator. Now, what that allows me to do is now I'm going to multiply both sides here by negative 5. Okay, so on the left-hand side, the negative 5s cancel. I'm left with just the f. And then negative 10 times negative 5 is going to be positive 50. So I like that. That worked out kind of nicely here. For this one right here, notice that they've written that in kind of a weird order. Don't really like to see the negative back there. So what I'm going to do is I'm just going to change the order. Instead of making it 17 minus t, I'm going to make it like minus t or negative t plus 17 is going to equal 12. Okay. Now I'm going to subtract 17 from both sides to balance that part of the equation out, and that's going to get me negative t is going to equal negative 5. And then the negative here is like having a negative 1 as a coefficient. So I'm going to divide both sides by negative 1, and in this case, I will get that t is equal to 5. Okay. So I'm hoping that you're seeing the same thing over and over again, regardless of the fact that there's some variation in the numbers that we work with, like the fractions. Sometimes it's division, sometimes it's multiplication, sometimes it's addition, sometimes it's subtraction. Sometimes there's a negative when I got to do multiplication or division, that it's the same thing, though, over and over and over again. So now, probably technically what should happen here is you give you some time to work on this on your own. So maybe what you might want to do is pause the video and have a look at some of these questions and try them first. I, however, am going to assume that you've done that. I'm going to jump right in and just start to solve these things. So if you've done it already, you can kind of check your work as we go here. So for this first one, again, I want to get the x by itself by removing that second term. So I'm going to subtract 4 from both sides, which case I'll get 3x is equal to negative 18. And now I want to get rid of the coefficient by division. And so x will equal negative 6. This one right here, don't really like the way it's written. I would much rather have this written in standard form. Be much happier if that x was up front. So now I'm going to get rid of the constant by subtracting 6 from both sides. So this will be negative 2x, okay, equals negative 8. Oops, sorry, I didn't mean negative 8 there. What I meant to say was 16. I was anticipating where this was going. Because the next thing that you're going to do here is you're going to divide by negative 2 on both sides to get rid of the coefficient. And then 16 divided by negative 2. There's your negative 8. Okay. On this next one here with the two terms, again, I'm going to add the 6 to both sides to begin with. So this will give us v over 8 is going to equal to 5. It's going to be equal to 5 there. And now, because I'm dividing by 8 on the left-hand side, I'm going to multiply by 8 on both sides here. The 8s will cancel. Okay, at least 8 divided by 8 is 1. And then 5 multiplied by 8 is 40. For this one right here, we are going to subtract 1 from both sides as our first step to get rid of that second term. And that will leave us with 2/3 k is going to equal to -16, or be equal to -16. And then I'm going to divide both sides by the 2/3, which really is going to be the same as taking that -16 and multiplying it by 3 over 2. Okay, and again, the way I kind of think this one through here is I see that 16 divided by 2 is -8. Sorry, -16 divided by 2 is -8. And I do that division first because it simplifies the number, or the number gets smaller. Then I multiply by the 3. -8 times 3 is going to be -24. This one is pretty good here. I think it's pretty straightforward, except for the fact that it's in the wrong order. I don't like that. But as soon as I subtract the 100 from the left-hand side and subtract it from the right-hand side, I end up with this. Whoops. -x is equal to 0. Well, and maybe I divide both sides here by -1, but that really doesn't matter on the right-hand side because 0 divided by -1 is just 0. This is an interesting question here, and you need to be aware of this and pay attention to it. When you get a question where the solution is 0, it's very tempting to think that you did it wrong. Okay, in fact, that is kind of the knee-jerk reaction of a lot of students when the solution is 0 to think, whoa, I've done something wrong here. And that's actually not a bad response to that. You probably do want to double check that you've done it correctly here, but that is okay. It is an acceptable answer. So don't let that kind of intimidate you too much here. This last one here, we got a lot going on. The first thing we got to do here is we got to add the 2/3 to both sides. So on the left-hand side, those two are going to cancel. I'm going to be left with 5/6 plus 2/3. And what I need is a common denominator. So I'm going to multiply numerator and denominator here by 2. And so that's going to get me 5/6 plus 4/6, okay, which is going to be 9/6. And that's still 1/2 x equal to 9/6. And I'm going to divide both sides by 1/2. Okay, which is going to be 9/6 multiplied by 2 over 1. And there's a couple of ways I can do this, but what you might do here is 9 times 2 is 18, 6 times 1 is 6. And then really quickly, 18 divided by 6 is 3. There are other ways that you could kind of walk that one through, but that one worked out quite nicely that way. So anyway, there you go. There's the kind of the model here. When you've got those two terms on the one side, you use addition, subtraction to move over the term that doesn't have a variable in it. And then you use multiplication or division to move over to get rid of the coefficient of the variable. And that should give you the solution.